Hi again. Okay, so hopefully you've got your student journal open to page 246. We're going to just do a little extra practice for you. In exercises 1 and 2, evaluate the 6 trig functions of the angle theta. Here's my angle theta. The 6 trig functions, remember, are sine, cosine, tangent. We're always going to take that of the angle, so that's of theta, and then we'll do the reciprocals as well. But before we do anything else, in order to find these, we need to know what the hypotenuse is. So you know that you have a triangle, right triangle of legs 8 and 15. First thing you need to do is solve for the hypotenuse. So 8 squared plus 15 squared equals c squared. That's what our hypotenuse is going to be. 64 plus 225 equals c squared. 289 equals c squared. I take the square root of both sides, and I get c equals 17. So that's reasonable. The hypotenuse is always the longest side. And then I can write my ratios. Okay, so sine theta is, here's theta, the opposite side is 15. That's a 15. Oh, let me try to rewrite that. 15. And the hypotenuse is 17, so that's it. That's what sine is. Cosine, if you'll recall, okay, is the adjacent side over the hypotenuse. So cosine is 8 over 17. And then tangent is opposite over adjacent. So that's going to be 15 over 8. And you just leave it like that. You don't have to, it's not like you reduce it as an improper fraction or something. You just want to know what those trig functions are. Of course, the other three, you're going to write cosecant is equal to 17 over 15. Secant is equal to 17 over 8. And cotangent is equal to 8 over 15. I don't have room on my screen to write that, but please put it in your notebook, and we'll move on to the next one. So we're on number 2. You'll notice again it's a right triangle, but now we have the hypotenuse and not one of the legs. So here's what we need to solve for. I'll call it b. It'll be 4 squared plus b squared equals 8 squared. 16 plus b squared equals 64. I'm going to take away 16 from both sides, and I believe I get 48. So once I get b squared equals 48, I take the square root of both sides. 48 is 16 times 3, so the square root of 16 is 4. That means now I can label this leg for root 3. Okay? Now, I'm going to erase a little bit here. So this is now going to be the work for number 2. Okay? Sine of theta. Theta's down here. Sine is opposite over hypotenuse. Just because it's drawn a different way, remember the hypotenuse is always the longest side, and it's always across from the right angle. So, of course, you would reduce that to 1/2. Cosine, then, of this theta is going to be the adjacent side. So this will be 4 root 3 over the hypotenuse, and again, you will reduce that to root 3 over 2. Hey, these numbers look familiar. I think we just did a chart with these in them. And then last, of course, we're going to do tangent, and tangent, again, of this theta is opposite over adjacent. So this is going to be 4 over, for root 3, you're going to reduce that to 1 over root 3, but again, we have to rationalize it, and it'll end up being root 3 over 3. So those are your 3 values for this theta. So again, in order to get the cosecant, you'll flip this upside down. Cosecant is 2. The secant, which is the reciprocal of sine, is going to be 2 root 3 over 3 once you rationalize it. And then, of course, tangent, you turn it upside down for the reciprocal, and it's just going to be root 3. So hopefully you can see how to do 1 and 2 easily. Now we're going to move on to number 3 and 4. So we're going to move on to number 3 and 4. Now it's going to be a little different. I said at one point you're going to get an angle and at least 2 sides, because then you can solve it with Pythagorean. But sometimes you'll get what those sides are equal to, and you'll have to solve for the angle. So in these two, let theta be an acute angle of a right triangle. Evaluate the other 5. So basically what we have to do is draw the picture, and then we can figure out, what it looks like. Try to make it as realistic as possible. If the opposite side over the adjacent side, that's what tangent is. Tangent is, okay. Tangent is opposite over adjacent. That means that I'm going to have a right triangle that has basically the same 2 sides. That's the only way I'm going to get a ratio of 1. So here's my right angle, and it doesn't matter where you put theta. So let's say theta's here. Then the opposite sign is going to be 1, and the adjacent side is going to be 1. That's the only way you can get tangent to be the opposite over the adjacent equal to 1. So if you know this is 1, then we have already solved for it. We also know that our hypotenuse is root 2. And so go back to the chart from the previous page, and you should be able to write all 6 right all 6 of those functions. Okay? And I'm going to move on to number 4. Number 4 says sine of some angle is equal to 3 over 19. So the top number is the opposite of where theta is, and the bottom is the hypotenuse. So you're going to draw a triangle that looks like that, where, okay, I've got an opposite side, so I've got a right angle, and then this is going to be really long. So if I label this, let's say this is theta, then the opposite side from theta looks like it's about 3. Okay, that's what it should be. And then this one, it should be much longer actually, but it's going to be much longer. It's going to be 19. And then we're going to solve here for b. You know how to do that. I went ahead and did the work there, so we don't have to waste too much time on that. But once you get that other side, then it says evaluate the other 5 trig functions. So that means, write down what they are. Figure out what those are. Okay? Hopefully that brings some clarity. The last 2, you can solve 2 different ways. And I'm going to show at least one, and then we will wrap this up for now. So in number 5, it just says find x. So we have theta here. This is the adjacent side, and this is the hypotenuse. So we ask ourselves which one uses the adjacent and the hypotenuse. Okay, that's going to be the cosecant. So ka is cosine, so ka toa. So we're going to write this equation. Cosine 30 is equal to, the adjacent side is x, and the hypotenuse is 16. Well, you know what? From our previous chart, I'm pretty sure we already know what cosine 30 is. We looked at it, remember in the previous video, the cosine of 30 is root 3 over 2. And if that's going to be equal to x over 16, this is a pretty easy equation that you'll be able to come up with. So I do believe you'll get x equals, so if you cross multiply, you get 16 root 3 equals 2x. You divide 16 root 3, and you get 8. So at least for this, okay, that's for number 5, you end up with x equals 8 root 3, which is a reasonable number. Now, in order to do number 6, obviously, I'm going to do some erasing. So while you're writing that in your journal there. Okay, so number 6 is going to be even easier. I've got an angle of 45, a hypotenuse of x, a leg of 20. Okay, here's the beautiful thing. If this is a 45, 45, 90, then these two legs are the same. You don't even have to solve for it as far as when you're evaluating anything else. But you should notice that, okay? So I still want to find x. In this case, I can use sine or cosine. Sine would be opposite over hypotenuse. And the funny thing is, if you wanted to do cosine, you could also do adjacent over hypotenuse. So both of these are going to give you the same answer, which is kind of nice. Let's just go ahead and use sine 45 equals opposite is 20, hypotenuse is x. There you go. Again, from our chart, we know that sine 45 is equal to root 2 over 2. So if I was going to continue with the work, it'd be root 2 over 2 equals 20 over x. I'd probably just cross multiply here. Okay, and I get 40 equals root 2x. So I would divide both sides, and I get 40 over root 2. Again, you're going to have to rationalize it. So I end up with x equals 40 root 2 over 2. And now we have to reduce. So x equals 20 root of 2. Ta-da! Okay, so that's a little more practice for you. You have those filled out, and you're going to use this information next week when we start to move on to 2. Actually, we're going to do some modeling before that, but we'll see you, have you do that on Monday. All right, talk to you later.